Okay, in this example, we're given that tangent of theta is negative 3/4 and that theta is located in quadrant 2. So we want to find the double angles for sine, cosine, and tangent as we go through this. So when we get going on this, notice that each one of these formulas, we're going to need sine of theta and cosine of theta in addition to this tangent of theta. So let's draw a triangle based on the information that we know already. The tangent of theta equals negative 3/4. So I'm going to draw a right triangle. I'm just going to locate theta down here in this corner. All right, so we know exactly which angle is going to be theta. And I'm going to go ahead and put 3 and 4 on the opposite and the adjacent sides, thinking SohCahToa. All right, now to get sine and to get cosine, we're going to need the hypotenuse of this triangle. And just kind of ignore that I left off the negative. We're going to use the information about this being in quadrant 2 to help us make sure we get the right sign on sine of theta and cosine of theta in just a second. But first, let's go ahead and work on finding the hypotenuse of this triangle. So I'm going to call that C for the time being and use the Pythagorean Theorem saying 3 squared a squared plus 4 squared b squared equals c squared. With a little bit of solving down here, we can say that's 9 plus 16 is going to equal c squared, or 25. As we combine those together gives us c squared. We're going to apply a square root to both sides, thus getting rid of the square and getting us c equals 5. You may recognize this as a 3, 4, 5 triangle. All right, from here, let's go ahead and identify. We can figure out sine of theta. Thinking back to SohCahToa is going to be opposite over hypotenuse, so 3/5. And then cosine, as we've drawn the triangle, is going to be adjacent over hypotenuse. Again, thinking SohCahToa. The last thing to kind of contemplate here is positive or negative for each one of these ratios. So this is where I go back to this phrase, all students take calculus. Because theta is in quadrant 2, we're looking at only sine is going to be positive. All students take calculus. In quadrant 2, only sine is going to be positive. That means tangent and cosine are going to be negative. So you notice that tangent was already negative from what was given to us. We need to make sure that we include a negative for our cosine of 4/5. So it'll be a negative 4/5 for cosine of theta. All right. All that remains now that we have sine and cosine is basically we just need to fill into these formulas. Won't take long at all. So here we have 2 times, we said sine of theta was 3/5, 3/5, and cosine of theta was negative 4/5, 4/5. A little reducing down here. I'm going to visualize that as 2/1. So we have 3 fractions multiplied together. We're going to multiply all of our numerators together. Again, negative 24. And our denominators, multiply those together, and we get 25. So negative 24/25. Okay, as far as cosine of 2 theta goes, we're going to replace the cosine of theta, again, with negative 4/5. Because it was cosine squared, whatever we fill in for cosine is going to get squared, minus, we're going to fill in for sine with positive 3/5. And because sine was being squared, whatever we fill in for sine, it also gets squared. From here, we just have a little bit more simplifying down to do. As we square these, I'm going to square the numerator and square the denominator individually. 2 negatives are going to make a positive when we square this as well. So we get 16/25 minus 9/25. All that remains is to combine these fractions together. We already have a common denominator, so we'll keep the common denominator. 16 minus 9 is going to give us a positive 7. So we get 7/25. Positive 7/25 is the double angle for cosine of theta. Last thing to do here, we have tangent of 2 theta. Now, tangent was originally given to us, so I'm referring back to that exact same value. We're going to be filling in negative 3/4 for each one of these tangent of thetas from what was given to us in the very original. All right, so as we fill in, this is going to be 2 multiplied by tangent of theta, which we just said was negative 3/4, and then 1 minus, again, negative 3/4 is going to get squared because it was tangent being squared. We're going to replace tangent of theta with negative 3/4 and then square it. All right, the rest of the reducing down here, let's go ahead and multiply 2 times negative 3 over 4. So that's going to give us negative 3 over 2. And then in the denominator, we can say that's 1 minus. And then when we square that negative, that means 2 copies of this negative multiplied together. I'm going to get 9 over 16. All right, this isn't the best answer we can get to, as we still have fractions inside of fractions. So to clean this up a little bit, what I'm going to go ahead and do is multiply both numerator and denominator by 16. My goal here is multiply by 1. Same thing, numerator and denominator is like multiplying by 1. But the goal is to get rid of these little fractions within the big fraction. So 16 is going to be a multiple of 2 and a multiple of 16. So from here, just a little bit of reducing down, we're going to say 16 times negative 3 over 2 is going to be negative 24. In our denominator, we have to remember to distribute this. So the 16 needs to be multiplied by both the 1 and this fraction. So 16 times 1 is going to give us 16, minus 16 times 9/16 is going to make a 9. All right, no more fractions within fractions, but we can go ahead and combine those like terms in our denominator and say, well, 16 minus 9 makes 7. This won't reduce down any further, so that's our final solution. All right, hope this helps. Draw the triangle, find sine and cosine if they're going to be needed, and that goes a long ways for filling into these formulas. Good luck.